Hi everyone, my name is Jingyu, and here I'm going to present to you what we do for this summer. We are Astrophysics Research Group, and we're from Agnes Scott College. And also thanks for the terrestrial interferometry observation. And this is our awesome group photos that we did this research by actually online or virtual, and this is one of the photos we have for our Zoom call. We love our group, and we are the pioneer for online research due to the COVID-19. So here comes some background that what we study. We study supergiant stars. A supergiant star is the most massive and luminous stars in the universe. They can have masses from 10 to 70 times greater than our sun, and their brightness can be from 30,000 times or brighter than our sun. And this picture tells you the scale between a supergiant star and the scale of our solar system, because it's really huge, right? And the supergiant star, they occupy the top region of the HR diagram. HR diagram is an astronomy tool for telling you the temperature and the luminosity of the star. And luminosity is just how much the energy the star putting out. And the supergiant star has onion shape structure. They have different layers of the heavy element in their cores. And the star is powered by the shell burning, which causes the strong stellar wind. So this summer, we study the temperature and angular size of B-type supergiant stars, and we want to know how much their stellar wind conditions affect the pre-existing models that we had. Our method is called spectrophotometry, the amount of energy transmitted or reflected by the star as a function of the wavelength. The left picture is a spectral energy distribution plot, SED plot. So this SED plot is for our sun. That's why you can see the peak spectrum peak is at optical. Instead of our study object, the supergiant will have the peak at ultraviolet spectrum. And we use the tool called literature search. Literature search is we collect data from the peer-reviewed articles. The websites we use is called the VZR and Sinbad astronomy websites. And we run the IDL programming to get our plots. And this screenshot just tells you we had a lot of programming IDL stuff going on for this summer. Here comes the result that we have two comparison plots. The first bar chart tells you the derived temperature versus the model temperature versus the literature temperature. And in general, the model temperature is lower and derived temperature is greater than the model temperature. So this fits our hypothesis that the model underpredict the temperature. And the right-hand side is the comparison plot for the star's angular size. We have 4 samples here. The measure size in general is lower than the model size, which also fit our hypothesis that the model overpredict the size. And while we only have 4 samples, that's because we only observed 4 stars with their angular size by the terrestrial interferometry observations. And in the future, in the fall semester, we're gonna have more samples here. But this summer, we also had all 20 star samples that we had the model temperature versus the literature temperature. And here we plot the scatter plot for them. The blue square just indicate the star with the UV data, ultraviolet data. And the red triangle is the star without the UV data. And we're gonna have more samples included in the future. And right now you can see that literature temperature is higher than the model temperature because most of the samples are actually above on the upper left of this equal line. This line is the y equals x line, which tells you when the model temperature equals to the literature temperature. And we calculated that literature temperature is 3.65% higher than the model temperature. Thank you so much for listening.